I'd like to use the unit circle again, and this time we're going to use the unit circle to help us evaluate the trig ratios at the angles 0, pi halves, pi, 3 pi halves, and 2 pi. Okay? So let's remember, given an angle theta and the corresponding point on the unit circle, then the following trig ratios are as follows. So let's go ahead and look at the unit circle real quick, and I'll go back to that page. Given an angle of theta, so maybe here's an angle of theta, and there's the point xy. So if we're given an angle, we can find that point xy. Then the following ratios are as follows. Sine of theta is just the y-coordinate. Cosine of theta is the x-coordinate. Tangent of theta is y over x. And of course, these are the reciprocals of the first three. Okay? So let's go ahead and try to find the corresponding trig ratios for these angles, 0, pi halves, pi, 3 pi halves, and 2 pi. We'll do those first. So what do we have to do? Well, in order to do these, we have to find the corresponding points. So given an angle of 0, 0 degrees or 0 radians is just this angle right here. We haven't started our rotation yet. There's no rotation. Okay? So this is an angle of 0 radians. Now, what is this point? That's what we have to figure out. Well, the point, remember it's the unit circle has a radius of 1, so this is the point 1, 0. So with an angle of 0, the corresponding point on the unit circle is 1, 0. Here's an angle of pi halves, or 90 degrees. Okay. And what is the corresponding point there? Well, the x-coordinate is 0. The y-coordinate is 1. Over here, that's an angle of pi, or 180 degrees. And that is the point -1, 0. The 270-degree angle, that's 3 pi halves. And that's the point 0, -1. And 2 pi is the same angle as 0. All right. So now, what we want to do, given these angles, we have found the corresponding points, and now we want to evaluate the following: sine, cosine, tangent, etc. And we won't do them all, but we'll do several. Okay? So let's go ahead and do 0. Okay? 0 degrees or 0 radians. Sine of 0, cosine of 0. I'll just do sine, cosine, and tangent because we could do the reciprocals to do the others. Okay? So, there's 0. The corresponding point is 1, 0. So the sine of 0, well, it's just going to be the corresponding y-coordinate. So the sine of 0, the y-coordinate is 0. So the sine of 0 is 0. Cosine of 0, well, that's just the x-coordinate. The x-coordinate is 1. Okay. Tangent of 0, that's the y-coordinate over the x-coordinate. The y-coordinate over the x-coordinate equals 0. Okay. Let's go up to pi halves. So let's find the sine of pi halves, cosine pi halves, tangent pi halves. You'll get the hang of this in a moment. All right. So now, here's an angle of pi halves. I know here's the corresponding point on the unit circle. So the sine of pi halves, that's the y-coordinate, 1. Cosine of pi halves, that's the x-coordinate, 0. Tangent pi halves, that's the y-coordinate over the x-coordinate. We have division by 0. We can't divide by 0, so we say the tangent of pi halves is undefined. Okay? Now let's do one more. Let's find the sine, cosine, tangent of pi. I'll leave the rest for homework. Okay, sine of pi. Well, here's an angle of pi, radians. There's the corresponding x and y coordinate. Again, the sine of an angle, if we're on the unit circle, is the y coordinate. So the sine of pi is 0. The cosine, that's the x coordinate, -1. And the tangent of pi, that's the y coordinate over the x coordinate, which is 0. Okay? So these are actually pretty easy to evaluate. Okay? For example, what's the sine of 3 pi halves? Well, that's the y coordinate, -1. Cosine of 3 pi halves, 0, etc. So make sure that you can do this. You might want to review this a couple times. Don't worry, I'll give you plenty of homework exercises to work on. Okay? And by all means, if you have any questions, come by the Polia Math Center, and we will get you straightened out there.